Before we get started, just two quick things. One, if you don't have a piece of paper, pencil, and calculator, please go grab that. And two, if you had trouble yesterday with understanding simplifying radicals, I just uploaded a video of me solving the practice problem, so take a look at that maybe before we get started here, because that is going to help us move into what we're doing today. All right, with that said, let's get started. So today we are going to be learning a pretty important geometric theorem. So theorems are just rules that we can say is pretty much certain based on repeated patterns that we see in math. So the one we're going to be learning today is called the Pythagorean theorem, Py. So you might be wondering, why does it have that silly name? Pythagoras was a great mathematician from ancient Greece, and this was named after him because of him and his followers kind of discovered this pattern, this relationship that we're going to be discovering today. So we're going to dive into this special relationship that deal with the sides of triangles. And the Pythagorean theorem specifically doesn't just talk about any type of triangle, but it talks about this type of triangle. So this is a quick sketch, but what type of triangle did I just sketch there? Right, it has to deal with right triangles. So right triangles, like every triangle, has three sides. But when it comes to the Pythagorean theorem and when it comes to right triangles, we're going to make a distinction with the types of sides that there are. So these two sides that I'm pointing to right here are going to be called the legs of a right triangle. And this side right here, that longest side, the one that's opposite the right angle, right here, is going to be called the hypotenuse. The hypotenuse is always that side, and they are each going to be represented by a given letter. So the legs are both represented by letters A and B. The order doesn't matter, so I'm just going to go ahead and pick that this side is going to be A, this leg is going to be B. But what's important to know is that the hypotenuse is always, always, always represented with side C. Okay? So we have two legs, and we have the hypotenuse. The legs are always represented by A and B. The hypotenuse is always represented by C. So I am going to just do a quick sketch here, and I'm going to give them random numbers, 3, 4, and 5. Which of those numbers is representative of the variable C based on the Pythagorean theorem that we're going to start talking about in a second? A, B, or C? Which one is C? 3, 4, or 5? All right, good. 5 is C. Now, when it comes to distinguishing if it's A3 or is A4, it really doesn't matter. I'm just going to go in order. I'm going to make A3, I'm going to make B4. Okay? So, each of these now have a relationship, and I'm going to put them next to it so we kind of have them labeled. Now, the Pythagorean theorem is a equation, it's a formula that we can use to find missing sides of any right triangle. And the formula goes like this. A squared plus B squared equals C squared. The square of the side A plus the square of side B will always be equal in a right triangle to the square of side C. Now, I specifically chose the numbers 3, 4, and 5 because that's a special right triangle. It's called a 3, 4, 5 triangle. And whenever you have a triangle that have the sides 3, 4, and 5, it's always going to be a right triangle. And let me show you why this Pythagorean theorem works. If I'm telling you I know for sure 3, 4, and 5 make a right triangle, then the Pythagorean theorem should work. So we're going to plug in 3 for A. We're going to plug in 4 for B. We're going to plug in 5 for C. 3 squared becomes 9. 4 squared becomes 16. 5 squared becomes 25. Now, if the Pythagorean theorem is true, when we add these two together, we should get an equivalent statement. And we do. When we add 9 plus 16, we get 25 equals 25. Now, I just randomly picked 3, 4, and 5. Could I have picked any random number? Well, let's see. I'm going to make a triangle. I'm not sure. I knew that 3, 4, and 5 worked, so let's see if I can pick just any other random number. Let's see, just going up the numbers 6, 7, and 8. If I do 6 squared plus 7 squared equals 8 squared, 6 squared equals 36, plus 7 squared equals 49, 8 squared equals 64. Then I have to add those two numbers together, and I get what? Right, I get 113. 113 does not equal 64, meaning this is not a right triangle. All right, so now let's go back to our right triangles here. So the great thing about this relationship, a squared plus b squared equals c squared, is if we know any two sides of a right triangle, we can find the third. So here's my quick sketch of a right triangle. And let's say I know both legs. I know this leg is 4, and I know this leg is, let's go with 10. Okay? So I'm in this situation. I know one is 10, I know one is 4. And let's go and dive deeper to see if we can figure out what is the value of the hypotenuse, this missing value. What letter should I be using to represent this side? Right, I should be using C because it's the hypotenuse. So it doesn't matter which is A or which is B. I'm going to switch it up now. I'm going to make this side A and this side B. Okay, so whenever I see A in the formula, I'm going to replace it with the number 4. So now A squared becomes 4 squared plus B becomes 10, so 10 squared equals C squared. We don't know what C is. That's what we're looking for. We want to know how long is the segment C. So then I do 4 squared is 16 plus 10 squared is 100 equals C squared. Then I add those two sides together. 116 equals C squared. I get 116 equals C squared, and now I have to go back to that idea that what we were doing yesterday in class. What do I have to do to isolate, fully get C all by itself? I need to take its square root to get C all by itself. To isolate C, to do the inverse operation of squaring, I'm going to take the square root of C squared, which is just C. Whatever you do to one side, you have to do to the other. So C is equal to the square root of 116. Now, that's all well and good, but we're not done yet. Because what do you think we have to do, or at least check to do, with the square root of 116? Right, we need to see if it can be simplified. So over here in my little sidebar, I'm going to do the work to see if I can simplify the square root of 116. Square root of 116 gets broken down into 4 and what factor? If you're breaking 116 down into 4 and what? 29. We can now go further with 4 into 2 and 2. Both of those are prime. Now the question to ask ourselves, is 29 prime? Can you think of any numbers that can be divided other than 29 and 1? Are there any other factors of 29? No, there's not. So 29 is actually a prime number, a pretty big one, but that's okay. So now we can rewrite the square root of 116 as 2 times 29. There's a pair of 2's that can leave. So it can be written as 2 square root of 29. So this is our value of C. Your other option is going on your calculator, starting from where we were here, and just finding what is the square root of 116. See if you can figure out a calculator to figure out how you can do that. Either type in your answer you got or tell me that you don't know how to do it on your calculator. You can also just type in square root of 116 into Google if you need to. All right. Now when I did that, I found the square root of 116. I get 10.7703, and so on. So the reason why we use this radical here is because otherwise you kind of get this crazy number. The crazy number is fine too. I will give you the directions when I say find the value of the missing side length. I'll either tell you write it in radical form or write it in decimal form. So the answers for C are either 2 radical 29 if I wanted it in radical form, or C if you were to estimate its value would be 10.77. All right, now let's see if you can do one, and let's give it a try. Here's a side, here's a triangle. It's going to be a right triangle, and I'm going to give you the side lengths 5 and 3. I want you to find this missing side length. Pause, see what you can do, try it out. All right, now that you've tried it, let's see if you got it right. I'm going to make A 5, I'm going to make B 3. Like I said, could be either, as long as it's not C. And I'm going to plug it into the formula A squared plus B squared equals C squared. A is being replaced with 5 squared plus B is being replaced with 3 squared equals C squared. 5 squared is 25 plus 3 squared is 9 equals C squared. 25 plus 9 equals 34 equals C squared. We then have to take the square root of both sides. Get the square root of 34 is equal to C. Now we can check, is 34 prime? It's not prime. Let's see if we can be broken down anymore. When we break 34 down into its prime factors, it's 2 is a prime factor and 17, which is also prime. When you rewrite that, 2 times 17, there are no pairs, so this is unnecessary. The final answer in radical form is just the square root of 34. Since it can't be simplified, you keep it like that. And if you wrote it in a decimal form, the square root of 34 is approximately equal to 5.83, which would be the approximate value of C. Okay. So now that we've done a couple of examples where we were looking for the hypotenuse, now we're going to switch gears a little bit. And what we're going to do now is I'm going to find the missing side of a leg. So we're going to make this side 10, this side 12, and this is the side we don't know. What are the two values I could use to represent question mark? Great. You can either use A or B. I'm going to make question mark B, B. I'm going to make this A. And then I'm going to make 12, what value? It has to be C. Hypotenuse is always C. Oh, I forgot my right angle. That always needs to be there. Alrighty. So now when we plug it into our formula, A squared plus B squared equals C squared, now I'm replacing A and C instead of A and B because I have the hypotenuse this time, and now I'm looking for a leg. So I'll replace this 10 squared plus our mystery number B squared equals 12 squared. 10 squared is 100 plus B squared equals 12 squared is 144. What is my next step going to be to isolate B? I need to subtract 100 from each side. When I do that, I get B squared equals 44. And then I need to do what? I need to take the square root of both sides. B squared, that's when you take the square root, just becomes B, equals the square root of 44. We have to check and see if the square root of 44 can be simplified. Are there factors of 44 you can think of? We can break it down into 4 and 11. Are either of those numbers prime? Yes. 11 is prime, but 4 is not. So we break 4 down into 2 and 2. And then we're going to see if we can rewrite it and take anything out. 2 times 2 times 11. The 2's are pairs that can be taken out. And 11 is left in the radical. So if we're trying to have the simplified radical form, that would be 2 radical 11. And in decimal form, it will be square root of 44 is 6.63324, and so on. So I'm going to just estimate that into 6.63. Let's see if you can do one of those problems. Here is your triangle. It's a right triangle. We know that this side is going to be 7. I'm going to label that, and then I'm going to make this side right over here 3. All right? Try to figure out what this mystery number is. And write it down in either decimal or radical form, whichever one's easier for you. Okay, so now you've given it a go, let's try. 7 has to be represented with C. 3 can be represented with A and B. I'll make it A. I'll make question mark B. A squared plus B squared equals C squared. Let's replace. A gets replaced with 3 squared. We don't know what B is. C is 7. 3 squared is 9. 7 squared is 49. We'll subtract 9 on both sides. We'll be left with B squared equals 40. We need to take the square root from both sides so that B is fully isolated. B equals the square root of 40, which we can break down. Square root of 40. Its factors could be 4 and 10. You might have taken a different way, that's okay. 4 gets broken down into, 2 and 2. 10 gets broken down into 2 and 5. So when I write that out, you get 2 times 2 times 2 times 5. There's one pair of 2's that we'll leave. And what's left inside is 2 and 5. So we'll multiply that back together, giving us 2 radical 10. So that's our value. B is equal to, in simplified form, 2 radical 10. And the numeric value of that, if you wanted to estimate it, would be B approximately equals 6.32. Now let's review all the things we just did. The Pythagorean theorem is A squared plus B squared equals C squared, where A and B represent the what? What did we call those sides of a right triangle? And where C represents the what? Good. A represents the legs, and C represents the hypotenuse. And we can use this formula to find missing values of side length. So if I am given both legs and I want to find the hypotenuse, then I can do it that way. Or if I am given the hypotenuse and one leg, I can use the formula to find the missing leg. And I'll just show you quickly each of these examples, and then you can go and try to do a couple examples on your own. So let's do this example first. 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. 25 equals c squared. Take the square root of both sides, and I find that c equals 5. And then moving over here, in this situation, I'm being given the hypotenuse, so let's find that missing side. I'm going to make a 4. I'm going to keep b as the missing value, so I'm going to make it 4 squared plus b squared equals 5 squared. In this situation, I get 16 plus b squared equals 25. Subtract 16 on both sides. Get b squared equals 9. And then to get b all by itself, take the square root, and I get b equals 3. Go back to this, watch it again if you need to. There are 5 quick problems for you to try on Classroom. The answers are at the bottom. I will post how to do each of those answers for next class, so you can check and see if you're understanding. If not, you could always ask for help. I am here for you no matter what you need. Have a great day, guys.